Hello. So right now we'll move on and discuss non-homogeneous linear constant coefficients equations. So these are equations of the form, for example, second order will be ay second plus by prime plus cy equals to f of x. So that's why non-homogeneous, so not zero here. So, and then of course, initial conditions, y of 0 equals to y0, and y of 1 equals to y1, right? Okay, so how to solve such equations? Or this second order, the third order will be ay third plus by second plus cy prime plus dy equals to f of x. With initial conditions, y of 0 equals to y0, y prime of 0 equals to y1, y second of 0 equals to y2, etc. So these are non-homogeneous differential equations with constant coefficients. So we are called them linear non-homogeneous constant coefficients, LNCC. So what's the strategy? First of all, step one, solve the homogeneous one. So the left-hand side, let's call it, let's give it a name so that I kind of basically don't go and just abbreviation of our notations. The left-hand side, whether second order, third order, or bigger order, is called the left L of y. Left or also linear. So L of y is a function on the left. So solve L of y equals to 0. And this is already known because to solve the linear homogeneous constant coefficients is already known. LHCC is known how to do. So basically the solution of the general solution of this is called y sub c. Y sub c is c1 e the power r1x plus c2 e the power r2x if we have two different characteristic roots and so on. This is the very same idea we did when we discussed homogeneous constant coefficients. Step 2 now. So this step 1 finalized by y sub c. And step 2, find a particular solution of this non-homogeneous equation. Find a particular solution of the non-homogeneous one. So find a particular solution is called y sub p. Y sub p satisfies L of y equals to f of x. So take a very close look at the reading materials I sent you. So the theory is there. Once you find the general solution of the homogeneous one, y sub c, and a particular solution of non-homogeneous one, then GS, general solution of the non-homogeneous, equals to y sub c plus y sub p. That's the whole theory. Add them together, add the general solution of the homogeneous analog plus a part or any particular solution of the non-homogeneous one is the general solution of the non-homogeneous equation. Okay, so let's try to provide some examples here. Examples at different levels of difficulty, so we have to be very careful of those examples. Example 1. So let's see. Y second minus y equals to e the power 2x. This is a simple example. And then let's see. Okay, we'll not put initial conditions because they're easy to deal with anyway. So only we waste some time, additional time, because once you know the general solution, then IVP is not difficult. Okay. So how to find the general solution here? By undetermined coefficients. So first of all, solution. Y sub c first. Y sub c is the general solution of y second minus y equals to 0. As before, characteristic equation is r squared minus 1 equals to 0. Characteristic roots plus 1 minus 1. So y sub c, the general solution of the homogeneous one, given the characteristic roots are 1 and minus 1, which are distinct, y sub c will be c1 e to the power x plus c2 e to the minus x. So this will be the general solution of the homogeneous analog of the non-homogeneous equation. So that's y sub c. So that's the step 1. Step 2, y sub p. Okay, so first of all, how does the method undetermined coefficients work? Look, f of x equals to e to the power 2x. So imagine that the following process. We keep differentiating f of x again and again, and make a list of all the linear independent, very important, linear independent terms which appear in the process of differentiating f of x again and again. So if we differentiate, let me put here like this. Differentiate, we get 2 e to the power 2x. Differentiate, we get 4 e to the power 2x. And so on. But notice that they are not linear independent. All the results we get subsequently are just multiples of the same unit e to the power 2x. So there is only one linear independent item appearing in this process. So only one linearly independent item in this process. So then there's the whole point, because y sub p is a linear combination of all the linear independent items appearing in this process. So y sub p was in a combination. Constant times the first one plus another constant times the second one plus another constant times the third one, etc., etc., etc. But we have only one of them. So y sub p, we look for y sub p as of the form a e to the power 2x. That's why this method is called undetermined coefficient. So as of now, a is undetermined coefficient. So we are looking for y sub p of the form a e to the power 2x. Okay, so let's try to erase this stuff here. And now we know what y sub p we have to look for. So y sub p equals to a e to the power 2x. What do we need for this y sub p? Y sub c must be a particular solution. Particular solution. So y sub p satisfies the equation. So yp second minus yp equals to e to the power 2x. Okay, so let's try to arrange to find exactly the value of a, which makes yp second minus yp equals to e to the power 2x. So yp equals to is a e to the power 2x. Yp prime will be 2a e to the power 2x. Yp second will be 4a e to the power 2x. Okay, so then we want y sub p to satisfy this equation. Yp second minus yp second minus yp, which will be 4a e to the power 2x, this being yp second, minus a e to the power 2x, this being y sub p. So what do you need? Yp second minus yp must be e to the power 2x. So what we got here? 4a minus a is 3a e to the power 2x equals to e to the power 2x. Well, since e to the power 2x is non-zero, we can simplify by a non-zero element. So we get 3a equals to 1. So a equals to 1/3. And therefore, we got exactly the undetermined coefficient a becomes determined. So from this moment, Formerly, A was undetermined coefficient, but after this work, and A is 1/3. So y sub p at this moment equals to 1/3 to A e to the power x, 1/3 e to the power x. We got y sub p. We got y sub c. So what will be now the general solution of the non-homogeneous? So once we got y sub c here, y sub p here, so that's the only thing we need. The y sub c in this one, y sub p equals to 1/3 e to the power 2x, right? So what will be the conclusion? Conclusion is general solution of the non-homogeneous equation is y equals to y sub c plus y sub p equals to c1 e to the power x plus c2 e to the minus x plus y sub p, which is 1/3 e to the power x. Right? So what about, for example, let's solve just for once an initial value problem. What about if we got the equation, the initial value problem, y second minus y equals to e to the power x. Let's put some simple condition. Y of 0 equals to 0, y prime of 0 equals to 0. How to solve this? So we already got the general solution of the non-homogeneous. GS is y equals to c1 e to the power 2x. Sorry, c1 e to the power x plus c2 e to the minus x plus 1/3 e to the power 2x. We need also y prime just to accommodate the initial conditions. Y prime equals to c1 e to the power x minus c2 e to the minus x plus 2/3 e to the power 2x. Now let's try to translate the initial conditions. Y of 0 equals to 0 means what? C1 plus C2 plus 1/3 equals to 0. So C1 plus C2 equals to minus 1/3. And then y prime of 0 equals to 0 means what? C1 minus C2 plus 2/3 equals to 0 equals to minus 2/3. Let's solve this system. This system, we add also equations together, we get 2C1 equals to minus 1/3 minus 2/3 is minus 1. So C1 equals to minus 1/2. Since C1 is minus 1/2, C2 will be is minus 1/3 minus C1 equals minus 1/3 plus 1/2. 1/2 minus 1/3 is 3/6 minus 2/6 is 1/6. So this C1, C2 equals to 1/6, and C1 equals to minus 1/2. So we got the solution initial value problem now that we know C1 and C2. Okay, so that's one easy case of the linear non-homogeneous. This is called a case with no duplicates. No duplicates case. No duplicates case. So what does it mean no duplicates? So there is no interference between the terms appearing in f of x and its derivatives. So f of x is e to the power 2x. If you differentiate, you get 2 e to the power 2x, 4 e to the power 2x, 8 e to the power 2x, etc., etc. There is no interference between those terms in the process of differentiating the three terms and the items in the general solution of the homogeneous equation. Now I want to show you an example of a differential equation in which we have duplicates. So duplicates. Example 2 is duplicates. Okay, so let's take a second example. Let's see, y second minus 4y equals to e the power 2x. Okay, I'll not put initial conditions, just a general solution. Find the general solution. Okay, as always, let's find y sub c first. Y sub c is the general solution of the homogeneous equation. Y sub c is the general solution of y second minus 4y equals to 0. Characteristic equation is r squared minus 4 equals to 0. And characteristic roots, we can simplify r minus 2 times r plus 2 equals to 0. Characteristic roots r1 equals to 2, r2 equals to minus 2. So base of solutions are e the power 2x, e the minus 2x, and therefore y sub c is c1 e the power 2x plus c2 e the minus 2x. Keep this in mind, very important. Usually this is easy, the easy one. Okay, let's moving on to y sub p. Let's look at the term e the power 2x. Differentiate, we get 2 e the power 2x. Differentiate, we get 4 e the power 2x, etc. We get only multiples of the same e the power 2x. There is only, as before, is the previous example, only one linear independent term to appear in this process. This will be e the power 2x. So the first take will not be correct, but first take, which is incorrect though, but I want to describe you the process of thinking. First take is what I say, linear combination of all the terms, linear independent terms which appear in this process. As before, the first take is y sub p equals to a e the power 2x. But what happens? We have duplicates. So this kind of overlaps with this term in the general solution of the homogeneous one. We have duplicates. So a e the power 2 is not good. What do we do in those cases? We have to multiply by the smallest power of x. Writing words is very important. If duplicates, multiply by the smallest power of x, such that there are no more duplicates with the terms appearing in the y sub c. Multiply by the smallest power of x such that there are no more duplicates. So that's the procedure. If duplicates, multiply by the smallest power of x such that there are no more duplicates. So yp equals to a e the power of x is not good. Instead, what do we get here? Y sub p equals to ax e the power 2x. And this one is good because I know ax e the power 2x does not appear in any of the terms in the y sub c. It does not appear in y sub c. So now we know that that's the process of thinking, which tells us, so if there are duplicates, so we discard the wrong y sub p and instead multiply by the smallest power of x such that there are no more duplicates. Okay, so I need to erase a lot of stuff here and only keep erase the work and keep the fruit of the work. So let's keep this one, ax e the power 2x. So keep this one. So y sub p after this thinking, y sub p equals to ax e the power 2x. A is undetermined coefficient. Okay, so let's continue from this moment. So we need y sub p to be a particular solution. So what do we need? y sub p to satisfy the differential equation of y second minus 4y equals to e to the power 2x. We need yp second minus 4yp equals to e to the power 2x. Right? That's what we need. So we need to fit A such that this equality is true. So fit A such that this equality is true. Okay, so let's continue then. Okay, so yp equals to ax e to the power 2x. Let's continue. We need to do we need to yp second, but in the process of getting to yp second, we have to do yp prime, yp second, and so on. So yp prime will be a product rule here. It's a e to the power 2x plus 2ax e to the power 2x. Because derivative, so we have two items here, derivative of the first times second times first one is ax times derivative of the second 2 e to the power 2x. So this yp prime. Yp second will be differential of the first one is 2a e to the power 2x. Now again a product rule. Derivative of the first one is another 2a e to the power 2x. That's why I will put plus 2a e to the power 2x. Derivative of the first and the second. Plus the first one here times the derivative of the second. So what we get here? 4ax e to the power 2x. Let me group together like terms. So or yp second equals to 4a e to the power 2x plus 4ax e to the power 2x. So that's yp prime, yp second. So what do we need? We need yp second minus 4yp equals to e to the power 2x. So what will be yp second minus 4yp? Yp second is this one, 4a e to the power 2x plus 4ax e to the power 2x. This is yp second. Minus 4yp minus 4ax e to the power 2x. This you can simplify this. Normally, the key of this method, because in the process of calculating yp second minus 4yp, like in this case, we have a significant cancellations, right? Which allowed us to solve the system, to solve for a. 4ax minus 4ax, they cancel. So we'll get 4a in the power 2x. This yp second minus 4yp is 4a in the power 2x. And then, what should it be? We need yp second minus 4yp. We need this to be e to the power 2x. So 4a e to the power 2x needs to be e to the power 2x. As always, the exponential is non-zero, so we can simplify by this exponential is a non-zero term. So we get 4a equals to 1. So a equals to 1 over 4, which means the undetermined coefficient now becomes determined. Okay. Good. So now we already got a. So y sub p at this moment is a being 1 over 4 is 1 over 4x e to the power 2x. Very important. It's a particular solution of the differential equation, which is solved by the method of undetermined coefficients like we did here. So the answer of the problem, y equals to y sub c plus y sub p equals to a sum between y sub c plus y sub p is the general solution of the non-homogeneous, right? So this will be y sub c c1 e to the power 2x plus c2 e to the minus 2x plus 1 over 4x e to the power 2x. And that's the general solution of the non-homogeneous equation. Y equals to y sub c plus y sub p. Okay, so let's do other ones. Okay. Let's take a random selection of other things. Okay. Example 3. Let's see, y second minus y prime equals to x squared. How to solve this problem? Okay. So first of all, let's try to do the y sub c part. Y sub c is we have to solve y second minus y prime equals to 0. Characteristic equation, as always, r squared minus r equals to 0. Or if you factor this r times r minus 1 equals to 0. Characteristic roots are 0 and 1. So y sub c is c1 e to the power 0x, which is just a constant c1, plus c2 e to the power x. c1 plus c2 e to the power x. That's y sub c. Okay, so y sub p then. First of all, let's look at the free term is f of x. This f of x is x squared, and keep differentiating. If you differentiate f of x is 2x. Keep differentiating. Differentiate 2x, get a 2. Differentiate, you get a 0. From this moment on, it also terminate because 0, derivative of 0 is 0, and we always get 0. So which are the linear independent terms which appear in this process? So y sub p equals to a linear combination of the linear independent terms which appear in this process. Is, let's see, you can say a plus bx plus cx squared. But is this good or not? Do we have overlap? Do we have duplicates or overlaps? Duplicates / overlaps. Question mark. Look at y sub c. These three terms are of the same nature with c1. So yes, we have duplicates. Since we have duplicates, we have to reject this y sub p. Instead of, so once we reject y sub p, multiply y sub p by the smallest power of x such that there are no more duplicates. So instead, y sub p equals to ax plus bx squared plus cx squared. So there's a process of thinking. So first, notice that what is the, so ground zero means y sub p is a linear combination of all the linear independent terms which appear in the process of differentiating the free term again, again, again. So it will be a times 2 is just the same with 1. 2x the same with x. So a plus bx plus cx squared. But because of this constant term duplicating this c1 here, we have duplicates, we have to get rid of, we have to multiply by x. Not by x squared, multiply by the smallest power of x so that there are no more duplicates. Now that we got y sub p equals to ax plus bx squared plus cx cubed, let's move it from here. So keep the fruit of the work and erase the work. So y sub p equals to ax plus bx squared plus cx cubed. Okay. What do we need? We need y sub p. We need y sub p to satisfy the differential equation non-homogeneous. So what do we need? Yp second minus yp prime equals to x squared. Okay, so let's calculate derivatives. So yp equals to ax plus bx squared plus cx cubed. Yp prime equals to a plus 2bx plus 3cx squared. Right? A plus 2bx plus 3cx squared, and yp second equals to 2b plus 6cx. Okay, now what does it mean yp second minus yp prime is x squared? So yp second minus yp prime equals to 2b plus 6cx is yp second. minus yp prime, so minus this. So minus a minus 2bx minus 3cx squared. So yp second minus yp prime. So minus a minus 2b minus 3cx squared. Okay, yp second minus yp prime. This should be x squared. Now what? Now we start what we call equalizing. Start to equalize. What do I mean equalize? Coefficient of x squared to the left equals coefficient of x squared to the right. Coefficient of x to the left equals coefficient of x to the right. 3 to the left equals to 3 to the right. Okay, so let's equalize. Let's equalize x to the power 2 to the left and the right. To the left, how many ways to get x squared to the left? Okay, let me use different colors. So we get a minus 3c. So minus 3c is the coefficient of x squared to the left. There is no other x squared to the left. Equals to 1. So minus 3c equals to 1. Okay, let's equalize the x to the power 1. X to the power 1. Coefficient of x to the power 1 to the left. Minus 2b here plus 6c equals to, there is no x to the right, is 0. And let's equalize the free coefficient x to the power 0 to the left and the right. To the left is 2b, right? 2b minus a. There is no other free coefficient on the left. So 2b is free, minus a is free, equals to 0. Okay, how to solve the system? This is a system of linear equations. So c, certainly c equals to minus 1/3. We got it. What about b? B equals to, if from this equation we simply divide by 2, minus b plus 3c equals to 0. So b equals to 3c. B equals to 3c, so b equals to minus 1. Okay, and then a, from this one, a equals to 2b, and b being minus 1 is minus 2. So we got a, now the undetermined coefficients now became determined. So what would be y sub p? ax plus bx squared plus cx cubed. So ax is minus 2x plus bx squared, so minus x squared, plus cx cubed minus 1, minus 1/3. C is minus 1/3, minus 1/3 x cubed. That's y sub p, that's y sub c, and then add them together. Y sub c plus y sub p is the general solution of the non-homogeneous equation. So we have to work out those problems so that we get used with this strategy of equalizing undetermined coefficients and find the solutions, find the general form for y sub p. That's the most important thing. Okay, so I'll see you tomorrow then. So keep an eye to Canvas. So I'll send you some more homeworks and ideas.